So before we start, a couple things to go over. One is that the machine is plugged in and the laptop is plugged in. Next, you want to make sure that the Ethernet cable, the red Ethernet cable, is plugged into the laptop. Before we start the machine, we'll start the laptop up and give that a chance to boot up. Next, we can turn the machine on, and that's done by the power toggle switch here. Next to that is an LED which indicates that the machine is powered on, and then in front of both of those is the emergency stop. The emergency stop will cut power to the pump if the operator needs to quickly shut the machine down. So now that the laptop's powered on, we'll turn the machine power switch on. You want to wait about 30 seconds for the machine's controller to boot up before we start the application software. There's two faint beeps that you might hear from the controller. This is an indication that the controller has booted. So once the machine has been powered up, if this is the first time that the machine has been run in a day, or it hasn't been run in a long time, it's a good idea to run the warm-up program. There's two applications on the laptop's desktop. One is called Warm-Up, the other is called iFit. The Warm-Up program is launched by double-clicking on the Warm-Up icon. Once the Warm-Up program is launched, we can choose the amount of warm-up time to run. The default is 5 minutes. We'll hit Continue. This is just a confirmation that we want to run 5 minutes of warm-up. We'll say yes. There's a message that ensures that you don't have a specimen in the fixture. So we'll say yes, we do not have a specimen in the fixture. Next, turn the pump on, and then start the warm-up cycles. At this point, the software will automatically run for 5 minutes. It runs a slow sinusoid of the actuator. This is done for a few different reasons. One is that it makes sure it gives you an option or an opportunity to see that the machine is operating. Secondly, it gives a chance for the hydraulic fluid to warm up. Thirdly, it lubricates the hydraulic seals. And then lastly, it gives the electronics a chance to warm up too before the iFit application is run. So if we were to allow this to run, it would run for its full 5 minutes and then automatically stop. If you need to stop the program before the 5 minutes up, simply click on the red stop button, shuts the pump down, and then you confirm that you want to quit the program. Next, we'll launch the iFit software. When the iFit software starts, a window will pop up asking to select the parameter file. Generally, there's only one parameter file, and you'll just choose the default. This is a file that defines all the details of the test, such as the test rate, preload, post-peak load. So here I'm going to show running a specimen from start to finish. The application has been started. I've got my specimen here ready. The machine is powered on. Once the application window is open, there's a summary of the test sequence given on the main page. So following that along will give you instructions on how to run the test. So the first thing it says is turn the power on. Next, enter the username, organization, specimen ID, and comments. Then you'll want to select a file name by clicking on the box next to select file name. You will need to enter in the specimen parameters. The specific gravity and air voids are optional. Thickness, ligament, and notch length must be entered. Default values for those are thickness of 50 millimeters, ligament of 60, and notch length of 15. Next, we'll position the actuator in the install position. This is done by clicking the green position button, and then clicking the yellow button that says go to install position. Now my actuator should be in a position which allows me to insert the specimen. Next, I'm going to align the specimen up by placing it in between the alignment marks on the roll pins, and then lining the notch up with the alignment plate. Next, I'll hit continue to close the position mover window. And then my start button has showed up. I'm going to hit start to start the test. It's going to automatically ramp to the preload, which was set at 0.1 kilonewtons. It'll ask me if the seat load is correct and to start the test, and I'll say yes. Once the test is done, the actuator moves back to the install position. Hydraulic pump shuts off. A summary of the test is displayed on the application window. Simply by clicking the reset button, the application goes back to the start screen and you're ready to run another test. Once the test is complete, the data files need to be post-analyzed to calculate the flexibility index. I'm going to show you an example here of software that was developed internally by TestQuip for calculation of the flexibility index. All the data files are pre-formatted for this software, as well as the software available from ICT or Illinois Center for Transportation. So calculating the flexibility index in this software is simple as selecting the load measurement button and then choosing the data file that was just created, double clicking on it, and you can see here the software generates a plot of the data. It shows the post-peak slope, calculates the fracture energy, and then also the flexibility index. So for the case of this sample data log, the flexibility index was calculated at 14.21. Other information related to the specimen is also displayed on the screen here. And then a copy of this plot is saved to the same directory where the data file is saved. The four blue buttons define the parameters of the file. Those parameters are stored in the parameter file that was selected upon startup. Under the Define button, you can enter in the test temperature, the contact load, the displacement rate, and the post-peak load. Normally these values shouldn't be changed. You will need to enter in the specimen parameters. The specific gravity and air voids are optional. Thickness, ligament, and notch length must be entered. Default values for those are thickness of 50 millimeters, ligament of 60, and notch length of 15. This defines system setup parameters such as the load limit of the machine. While the capacity of the machine is higher than 10 kilonewtons, it's currently set at 10 kilonewtons. This is because calibration is only done up to 10 kilonewtons. The install position, which we'll talk about in a later segment. The jog rate, which is how fast you want the actuator to jog when moving to a new position. The toggle increment, which is if you're manually jogging the actuator, the displacement between each button click. The scan time and sample rate, normally these wouldn't be changed, and they're set at default values of 120 seconds and a sample rate of 40 hertz. And then at the end of the test, if you wanted to save an image of the plot and return to the install position to get ready for another test. And under the scope button, you can define the parameters of the test scope. The max load and displacement are the values on the y-axis, and the scope time will be the time series along the x-axis. Hit continue when done. If I needed to adjust the install position, what I would do is I would go back to my position mover window, and here there's up and down arrow buttons, and I can manually jog the actuator up or down. In this case, the up arrow actually moves the specimen closer, moves the actuator closer to the specimen. So it's a slow jog. This is a value that was also set in the parameter file. The amount each button click jogs the actuator. It's a very small amount so that you don't accidentally come into contact with the specimen when you don't need to. So in this case, I'm going to change the install position from 25 millimeters to 26 millimeters. And if this is a value I want to save for every test, I would hit continue to close the position mover window. I would go into the setup window by pressing the setup button and change the install position here to 26 millimeters. I would hit continue, and now when I hit the position button again, you can see that the install position went from 25 millimeters to 26 millimeters. So we can double check that by hitting go to install position. Now I can verify by looking at my average LLD displacement that it's also 26 millimeters.